A chemical equation shows us the substances involved in a chemical reaction, the substances that react, reactants, and the substances that are produced, products. In general, a chemical equation looks like this. Reactants yield products. According to the law of conservation of mass, when a chemical reaction occurs, the mass of the product should be equal to the mass of the reactants. Therefore, the amount of the atoms in each element does not change in the chemical reaction. As a result, the chemical equation that shows the chemical reaction needs to be balanced. A balanced chemical equation occurs when the number of the atoms involved in the reactant side is equal to the number of atoms in the product side. Let's take a look at an equation representing a chemical reaction. N2 plus H2 yields NH3. In this chemical reaction, nitrogen N2 reacts with hydrogen H to produce ammonia, NH3. The reactants are nitrogen and hydrogen, and the product is ammonia. If we look at this equation, we can see that the equation is not balanced. N2 plus H2 yields NH3. The equation is not balanced because in the reactant side, there are 2 nitrogen N atoms and 2 hydrogen H atoms. In the product side, there are 1 nitrogen N atoms and 3 hydrogen H atoms. The number of the atoms is not balanced on both sides. To balance the chemical equation above, we need to make use of coefficients. A coefficient is a number that we place in front of a chemical formula. In this chemical equation, to make the number of nitrogen N atoms equal on both sides, we first place a coefficient of 2 in front of NH3. N2 plus H2 yields 2NH3. Once we do that, the number of nitrogen N atoms on both sides is balanced. However, the number of hydrogen atoms is not balanced on both sides. We need to make use of another coefficient in front of H2. This time, we put a coefficient of 3 in front of H2 to balance the chemical equation. N2 plus 3H2 yields 2NH3. The equation is now balanced. There are 2 nitrogen N atoms and 6 hydrogen H atoms on both the reactants and product side. Since there is no coefficient in front of N2, that means the coefficient is equal to 1. Practice always makes perfect. In general, to balance an equation, here are the things we need to do. Count the atoms of each element in the reactants and the products. Use coefficients. Place them in front of the compounds as needed. The steps are simple, but it is a process of trial and error. Let's take a look at a few more example equations and techniques that can be used to balance each one. This is a reaction between ferric oxide, Fe2O3, and carbon C, producing iron Fe and carbon dioxide CO2. Fe2O3 plus C yields Fe plus CO2. This reaction is not balanced. First, we need to balance the oxygen atoms. We do this by making it so there are 6 oxygen atoms on each side. To do this, we need to put a coefficient of 2 in front of Fe2O3 and find a coefficient of 3 in front of CO2. 2 Fe2O3 plus C yields Fe plus 3 CO2. Now that the oxygen atoms are balanced, we need to balance the iron Fe atoms first. To do this, we need to put a coefficient of 4 in front of Fe in the product side. Now that the Fe atoms are balanced, we can balance the carbon atoms. We do this by putting a coefficient of 3 in front of C in the reactant side. 2 Fe2O3 plus 3C yields 4 Fe plus 3 CO2. The chemical equation is now balanced. When to the law of conservation of mass, the mass of the reactants should be equal to the mass of the products when a chemical reaction occurs. This means that the number of different atoms involved in the substances reacting must remain unchanged after the reaction occurs. Where there is a chemical reaction, there is a chemical equation. The chemical equation needs to be balanced so that it follows the law of conservation of mass. A balanced chemical equation occurs when the number of the different atoms of elements in the reactant side is equal to that of the product side.